So how many of you like drawing the free body diagrams first? I think, okay, and then how many of you like to decide which free body diagrams as you go along? And some of you probably are still trying to determine. But what Rachel said was a great point, that you also want to, at times, just take the whole thing and separate it from its supports, which is the free body diagram that I didn't do here. There should be a free body diagram of the total thing. Okay, so are we okay moving to another problem, or do you really want to find out the values? I think you know how to do moments, right? You can do all that. I can email you the solutions. You want me to do that? Yeah? Okay. So we looked at these 3 problems already. And I want to go to a 4th problem. So we finished doing a bunch of 2D problems. And remember, your 2D homework is due on Thursday. So now let's take a look at this one. And DJ, we're up to you. Okay, we're doing this one. This sheet you have already. It's the one I gave you last week. So, the triangular plate of uniform thickness shown in the figure has a mass of 400. Given mass is equal to 400, what's the first thing I do when it's mass?
Change it to weight.
Change it to weight. 400 times 981 is...
I don't think we have that one.
No, you do.
Yeah, top 2 problems, but the bottom one is the one that's due on our sheet. Yeah, this is the one.
Oh, right, because I didn't copy that one for you. Okay, so sorry, you don't have it. Sorry. Just read it. It's not that hard to draw. That's right, because I just wanted to do 2D. Where are we? Okay, somebody do the math. 400 times 9.81. 36, well, almost 4,000. What is it? 39.98.
Yeah.
Is that right?
I don't know.
Come on, I'm on a calculator.
24.
What?
39.
Ralph? 39.24. Determine the tension of 2 cables supporting the plate and the reaction at the ball support. So DJ, what do they want us to find?
The 2 tensions,
So what do you want to call them?
T and TB,
Good. And?
the reactions at the ball support.
Right, what reaction do we have at that thing?
Is that just it's just resting on top, so normal?
Yes, it's just the normal. What do you want to call it?
N.
Good. So let's just call this is my scrap. TA. TB. Normal.
And if I put an NG, just
You can call it whatever you want. NZ, NC. Okay, so let's draw the moment, forces, magnitude, direction. Radian. So what forces and what stuff is here? What forces and moments are present? Weight. Do we know the magnitude? Yeah, just give it. And we know the direction. What else is there? What? And do we know the magnitude? No. Direction, yes. And then there's TA and TB, right? We don't know, but know this. How many unknowns are there? 3 unknowns. How many equations? How many free body diagrams? 1. So Terlin, what body do you want to draw a free body diagram of?
the plate.
The plate. There's only one body there. the plate. Maria, what's the location of that weight?
It's,
From the x-axis, what's the distance?
so it's at 1/3.
1/3, so it would be?
So 1,500 divided by 500.
500. And how about in the y? In the y, what's the distance? Maria, still?
So 2/3
From the y-axis, though. Measure it from the y-axis. Is it 1/3 or 2/3 from y?
so 600.
Try again.
300.
300. So 900, so this is the fatter end, right? So it's 1/3 over. From this end, this is the fatter end, so it's 1/3 over. Okay, so how many equations do we need? Excuse me. 3 equations. So Eric, what equation do you want to do first that would have one unknown in it?
Just one.
Yeah, find an equation that you only have one unknown in it. Let's do this. What I find helpful is I always circle the things that are unknown that I don't know. So I'm going to circle the tensions and the normals.
Would be the,
And the weight I know, right?
yeah,
3924
oh, so it'd be the sum of the moments about the x.
Right. Does it make it clearer when we circle the unknowns? Right? And we put the value in for the weight rather than put just the W there? So if we did sum of the moments about X, what would we solve for, Eric? Ed. Enrique, you have another equation you want to do where there's only one unknown in it?
Some of the moments about the y.
That's right. And what would you be able to calculate?
TA.
Right. Does everybody see that? Some of the moments about the x-axis allows us to find n because the only things in the equation would be n and w. Some of the moments about y would allow us to find TA because the only thing in the equation would be TA and w. So that would be some of the moments about x, we find n. Some of the moments about y, we find TA. And then Uriah, what would our third equation be?
It would be some of the forces in the y.
Some of the forces in the,
The y.
not y,
Oh, in the z.
z,
that's
right, 3D. The third
Okay.
equation would be sum of the forces in the z. So, and I'll photocopy all the math, okay? But in the meantime, I'm just gonna write it over here because it's just. So for this problem, do we have a number that it is? 676, right? 6-76, we did sum of the moments about the x-axis 0, and we were able to find n. And then we did sum of the moments about y equals 0, and we were able to find TA, correct, TA? And then we did sum of the forces in the z equals 0, and what did we find? TV. What can we always do in statics? Check. So what can we do a check? What equation can we use as a check? How about some of the moments in the z?
Sure.
No, look at it. Some of the moments in the z. Does that provide me an equation?
No.
No, because there are no moments in the z. Why?
Because they're all.
Because the forces are only in the z. What, any other kind of moment we could do? How about do it about a point? How about some of the moments about B? Or some of the moments about A? Or some of the moments about C? Or some of the moments about the point where W is?
Yeah.
Right?
Work.